All right, awesome. Thank you. So first off, I have a Google Drive link that I'm just going to drop in the chat. And that contains the script that we're going to go through today, a Python script, and then the PowerPoint that I'm just going to show. Okay. Now. Okay. Do you see my screen? Let me pull up the chat so that I can monitor that too. Okay, awesome. Okay, well, hi everyone. I'm really excited to be here talking about how we can use Python within R. We're going to use a package called Reticulate, and it makes it really easy to use Python in a number of different ways within our R scripts. So the first thing that we're going to do is install Reticulate. So this is just our typical way that we install in R, and Reticulate is the library that we'll be installing. So while this installs, I'm going to talk a little bit about what this is installing other than just the R stuff. So you're also installing a package manager for Python right now called Miniconda. And so this is kind of a lightweight version of a package manager that is commonly used in Python called Anaconda, except that this doesn't come with some of the interactive things like Jupyter Notebook and Spider, if you're familiar with either of those. The second thing that it's doing is it's creating a Python environment called RReticulate. And so this is important to know because this is where we're going to make sure we're installing our Python packages. You don't need to use this Python environment if you don't want to. If you are used to using Python and you have an environment set up with packages that you want to use, you are welcome to use that environment. And also this RReticulate environment can be used in regular Python applications. So this is all to say that it's not a special environment. It's just the one that they automatically create. And that's the one I'm going to be working with just so that I have a fresh environment that I can show you all how to go through. So there are a few ways that we can use Python within R. We can use Python code blocks in R Markdown. I'm not going to get too much into this, but I will show you pulling up the code block. But this is just, you would program regular Python. And so if you knew Python, you could do that. If you found code online, you could copy and paste and it would be exactly same syntax. You can then use Python interactively within R. And I will show you how to do this. We'll use Python commands directly within an R script. So there's a way that we can actually import our Python packages and use those commands just like as if they were R commands. And then lastly, I'll show you how to source Python scripts. So if somebody gave you some Python scripts that did something that you wanted to just pull into your R script, I'll show you how we can do that too. Before we get into the fun stuff, we have to look at the data type and syntax differences because if you've tried to program in Python and R, you'll know that there are some differences that will get you caught up. So one thing that is good to know is that by Python data types will be converted to the equivalent R type. So this is a table of like what our Python type would be and then the equivalent R type. And so this is important when you are typing in your R Python commands, the reticulate commands, because in Python, if something has, for example, square brackets, you're going to want to make sure you do it the R way of doing that, even though it's within a Python command. And that won't make maybe a whole lot of sense right now, but we're going to see some examples when we get into coding. One other thing that trips me up quite often is that true and false in R is capitalized, but in Python only the first letter is capitalized. So if you don't keep this in mind, it will kick you back an error. And then another good thing to know is that in Python, we typically use the period between when we are saying the library we're using and then the function from that library. We put a period in between, but when we're doing that in R, we want to put this $sign. So now I'm going to switch into RStudio, and we will first look at doing the R Markdown. So here's my RStudio, and I have already opened a new R Markdown document. I'll make this a bit bigger. And so to use Python within R Markdown, it's really simple. All you need to do instead of writing R is that you would write Python here, and then we could write our regular Python code within that cell block. So that's one way that you can use both in one if you're using R Markdown, but I'm not going to get super into this because I don't want to get into some of the details of R Markdown. So we are going to look at the interactive way next. So first, I'm gonna just open a new R script, and I am going to bring in reticulate. So I'll just do this your typical R way, nothing special here, library reticulate. And then I will run that. So now I'm gonna go down into the console, and I'm gonna work down here. We notice that when we're in R, we have the 1 greater than symbol, but when we're in Python, we're gonna have 3, and that's how we're gonna know if we're working in an interactive Python session. So to get interactive Python in the console, you type REPL _ Python. And then your parentheses, and you can run that, and then you'll see that it will bring up something like this, where it says your Python version. And then it's going to say that your Python environment that you're using. So mine is this R reticulate environment, and yours likely will be too. Although I did see online that some people, it has your default Python environment. So just be aware of what environment it's showing that you're working in, because we'll need to know that later. And then lastly, we have our information about reticulate. So now we can type in Python just like we normally would. We could set variables equal to things. We can print strings, just our usual Python things. And then to exit this, we can do Control-C, and we just get back to R. So that's a way if we want to use Python just briefly within the console. But let's talk about if we want to write a script and use some of the packages from Python. So I'm going to go back up here to my script here, and we're going to start by installing some Python packages into your Python environment. So to do this, we're going to use conda install. And this is part of reticulate. So when we do this, we are going to first define the Python environment that we're working in. So we're working in R reticulate. And then we'll put what Python package we want. So we're gonna download Xarray, and we're gonna download matplotlib and car2py. So I'm gonna type those all in, and you can follow along this and then run those so they're installing while we talk about them. Matplotlib, and then conda install. So because I wanted to show a mapping example, we're going to be using 2 different plotting packages. We'll use matplotlib and car2py. And then Xarray is the package that we're going to use to import our data. And the data that we're using is actually part of the like tutorial package, so we don't need to download it. It's already part of Xray once we install these. So when you are installing Cartopy, we're just going to add one more flag here, and we're going to say forge equals true. So this is the first time when I need to do capital other than lowercase. So I see someone has a question, or your hand is raised. I assume that means you have a question.
Hi, Sarah. I didn't know if you would be okay with us jumping in and asking questions.
Yeah, definitely.
Thanks. Here, let me turn my, sorry about that. There we go. So I ran the first Python to see what version, and it's asking me to install Miniconda. Is that what we're doing right now, or is that a separate?
Yeah, yes. So Miniconda is part of Reticulate, or it comes with Reticulate. So we do want to make sure that we're installing Miniconda, and then it might also ask you about creating the Python environment RReticulate, and you'll want to say yes to that too. So any of the installation options that come up with that, you'll want to agree to.
Okay, thank you. I appreciate that.
Yeah, no problem. Sorry, I didn't clarify that in the beginning.
Sarah, could you maybe throw the code up again, or just like paste it into your script to do that step, if you have it on hand?
Yeah. Yes. So all you have to do is your install.packages reticulate, and all the rest of the stuff will come up as a prompt.
Oh, awesome. Thanks.
Yeah, so as long as you've installed reticulate and everything installed correctly, you should have this Python or Miniconda already installed. But if you already have Python on your machine, it might be a little different. It might not have automatically installed Miniconda because you already had a distribution, but I'm not 100% sure about that.
Yeah, actually, that was a question of mine, was because I've already got Python. If I'm telling someone, is that they might not see this, it might automatically just pull it in, right? Okay.
Yeah.
Okay.
Yeah, and if you already have Python, you could say no to the Miniconda, and I don't think it would mess anything up, but I have tested this only using Miniconda, so I can't guarantee you wouldn't run into something unforeseen.
Hi, Sarah. So when I execute the X array and it comes to the next line with the plus sign, that requires to go ahead and install something else. Oops, my series.
What is it asking you to install with Xarray?
It just goes to the next line and has a plus sign.
Sometimes that can, at least in RStudio, that can imply an unmatched parentheses.
Okay.
So check that.
Oh, okay. Yeah. I see that. Yeah. So
Thanks,
I'm
Michael.
actually using. Yeah. Thanks, Michael.
Okay. So once we have all these installed, we can move on to start using them. So I'm just going to make sure I have them installed. I know I do, but I'm going to make sure. Okay. So hopefully yours are installing well and you aren't running into any errors, because now we're going to start using these. First, we need to import them into our script. So these lines are just installing these, so you only need to run this once. This is essentially the Python equivalent of this, your install packages thing. So now we need to import our packages into this script. And so to do this, we are going to nickname our package. So for example, matplotlib, we use PLT commonly in Python. And so we're going to assign that using the arrow. We're going to say import matplotlib. Now, I don't want to import all of matplotlib because there's only one chunk of it that I'm going to be using. So I'm going to put .pyplot. And so that way it just shortens what I need to type a little more. So once we've run that line, we can see that we have this PLT module in with our data. So that's our Python module. And so we're just going to do this again with xarray the same way we just did, nicknaming it XR. And then when we come to car_to_py, we're going to import this in two different ways because we're importing just two portions of this package. So first I'm going to nickname one CCRS. We're going to import car_to_py.crs. And then our second car_to_py one is feature. We're going to import car_to_py.feature. And I'll give you all a second to catch up while I run that.
Hey, Sarah, I got a quick question.
Yeah.
So when you're importing part of a package, is there a reason that you might do that or a library, I guess? Sorry. Is there a reason that you might do that rather than installing the whole package or loading the whole package?
Yeah, so a lot of times people will only do part of it because it just shortens the syntax. So for example, if I could say import matplotlib, but then I would need to type .pyplot. So by doing this, I'm just setting a nickname to just this portion of it so that I don't need to type more later on in my script. Okay, so once these are imported, and we see that they are because they show up in our data, we are going to take the test data set. So I'm going to name this air temperature. And so this is an xarray tutorial data set. So it downloaded when you installed xarray. And so to get to this, we're going to do XR to tell it xarray. And then where we would normally have a period in Python, we have our $, and then tutorial. Then we have another $, open_data set. And then the data set we're going to tell it to open is called air temperature.nc. And so we don't need a path or anything for that because the .tutorial part of this statement told it that this is a tutorial data set. So we can run that line and we see that we do have an xarray data set called air temperature now loaded in. So that worked. So now that we have this air temperature data set, I want to just create a map of the air temperature over the United States. So the first thing I'm going to do is name a figure fig and use PLT figure. And so this is a Python command that we use in matplotlib. We would use plt.figure in Python. And so we then are going to tell it the figure size that we want. So now in Python, typically after fig size, we would use square brackets for the size. So I would say square bracket 15, 5. But because we're in R now, we want to use the round brackets and put a C here. So that's just one way that we're using our R types within the Python syntax, is that even though this is a Python command, we want to make sure that we're still using our R syntax here. So now we'll run that and we'll have a figure up in our data, but we won't have a figure pop up yet because we haven't told it to show that figure yet. So the first thing that I do before I actually apply any data to this figure and start building on our figure, I am going to tell it the projection that we want to be plotting on. And I'm going to name it AX because this is our axis that I'm defining. And so I'm going to say PLT $ axes, and then my projection equals CCRS, and then the projection is called plate carry, I think. I don't know how to pronounce that, but this is the projection that we're going to use here. And so we imported CCRS up above, and this is just, it just has the projections, and this is one of those projections. So I ran this, and oh, this needs parentheses at the end of it. So I should run this and not get any error. And if at any point you want to see what I've done, the finished code is posted on that Google Drive. So next I'm going to set the boundaries of my axis. So I'm just going to say AX, use a $, and set the extent. And so here I'm using my R types again versus my Python types, and I'm just going to set the latitude and longitudinal extent for the United States, because I know that that is what this data shows, 0.5. And I know that these are my coordinates only because I looked at this earlier and figured out which coordinates work. So there isn't some secret that I'm looking at here. So we can run this. And so we get an error, and it's just a depreciation warning. So we should not have an issue, even though we do get this red error down here. It just has to do with matplotlib. And so now I'm going to add the coastlines and add states. So to do this, I'm just going to use my AX, use a $, and then coastlines. And then I'm going to do this again to add a feature and add states. And so the feature is part of the feature car2py.feature library, which we imported as feature above. So then we use a $, and states. So I'll run those because I didn't before. This coastlines will also turn up a depreciation error or warning, but it should be fine. So then once we have all of this, we can plot. So let's name our plot. And we're going to use our air temperature data set. And so X-ray data sets have some plotting like knowledge within them. So you can use X-ray to plot sometimes. So because this is an X-ray data set, we can say we're taking from that, and then we'll use the $ and then take just the air variable out of this. And then we want to select a time. So then we're gonna do another $ and then .se, or then just SEL time equals, and I know that this data set is, I think, all of 2013. So I'm gonna pick today's date in 2013 to plot. And I'm gonna give it a method, and that is nearest. And so what that's doing is saying I'm selecting this time period, but if that exact time is not in our data set, we'll take the nearest one. And then I am going to put a $ and say plot. And I'm just gonna enter down here so that we can see it all a little better. And then in plot, I'm going to tell it what axis projection we want to use. So I'm going to say AX equals AX. And then we need to do the transform again, just so that it knows what projection we're using. And so our transform equals CCRS, just as we did above. Plate carry. And then our parentheses. So if you've done this all correctly, I will make this smaller here. This will create a plot figure, but it won't pop up a plot yet. It won't pop up our plot until we say PLT $show, not percent. And then I get a user warning, which I did not get when I was practicing this.
Sarah, actually, I'm running your code on Google Doc, and there's a line for giving a title, and this line also gives a error, which /m is an unrecognized escape in character string starting air temperature.
Yeah, so the code online, it should be /n and not /m.
Oh, okay.
Yeah, that's a mistake I made. I need to update that. Sorry about that. So I'm not positive why this didn't pull it up. So I'm just gonna open up my script that I have on Google Docs and run that, and that one should work.
Your code worked for me, if that helps.
Yeah.
That does help. Okay. Well, I didn't want to do this part down here yet. Well, it should work. I'm just gonna restart R and then run this whole thing. Okay, now it works for me. So I must have done something incorrectly in my coding, but I got this pop-up figure, and this should be what you all got as well if you did the things that are shown in my in my script on the Google Doc, and not exactly as I was doing. But this is our figure. And so we can interact with it just as if it were an R figure. So this shows how we can use Python commands in R. So the last way that we can use Python in R is that we can take a Python script that's already written and import it into R. So I'm going to close this figure. And I am going to pull up this Python script that I wrote ahead of time. So I'll make this a little bit bigger because I want to talk about it briefly. So this is exactly what we just did, but in Python. So these are the same things that we imported before, except shape reader, which we don't need in this. But these are all as we read in before. And then this function, or this script, defines a function called plot air temperature. And then all of this is just like what we just did, except the Python version. So you should see that the syntax is pretty similar, except that the periods are $signs, the square brackets are now C and round brackets and things like that. So if somebody gave you this script and you wanted to use this in R, but you didn't necessarily want to like convert all of these commands over, we can just import this. And so this also is a cool function of reticulate. And if I go back to my RStudio window, I'm going to go back to here just so that I'm writing new. Okay. And so we need reticulate again. which I restarted R, so I just wanted to make sure I still had that. So now we're going to use something called source Python. And so in source Python, we're just going to write the name of our Python script. So our Python script is called Python underscore plot air temperature dot py, or it's plot air temp, I guess, not temperature. So I'm just gonna source that. And so if that is in your working directory, it will find it. If not, you might need to give it a path to that. But that's how you will source a Python script. And so you can see that now our plot air temp function that I just showed you in that Python script, we can see that that has been imported. So now if we want to use this function, you would type plot air temp. Where am I typing? Okay, plot air temp, and then in parentheses, I'm going to put the time because this function that I made takes the time. So I'm going to write 2013 04 14, which is the same. This is the same time that we just plotted. And then I'm just going to run that. And the Python script ran and made the same figure. But we didn't need to import all of those commands into R. We could just use an already written Python script to do this. So to summarize the different ways that we can use Python within R, we can create an R Markdown cell that's Python, and we can program in Python just as we would in any sort of Python IDE. We can then, we could also open up an interactive session within the console. And that way we can also just use our regular Python commands. We can import our libraries with Reticulate and use the commands just as we would in Python, but with some syntax changes. Or we can import a Python script by sourcing Python and just run Python definitions that we've already created in other scripts. So does anyone have any questions? That's all I have for you about using Python and R, but I hope that this has been enlightening and how you can work together, Python and R.
This is very cool. Thank you. So really quick, I want to make sure I heard you correctly earlier. I might have missed it. If you're working through our Markdown, you can basically treat that just like a Spider or Jupyter Notebook, basically, and but as long as Articulate is installed.
Yeah. Yep. So
Okay.
when you install Reticulate, what it does for our Markdown is it just sets up sort of the back end Python of it. So when you open up a cell, yeah, you can just type just like you were doing it in Spider or Jupyter Notebook.
Wow. Okay. And then really quick, just stepping back for a second, are there scenarios or situations where you found it better to do something like this as opposed to work in Python and then convert to R, or is this really just trying to meld the worlds? Or is there an example where this has been extremely helpful as far as connecting these two worlds?
Yeah. So
Does that make sense? Am I making?
Yes. Yeah. Definitely. So one way that I think that this has been helpful for me, at least, is that sometimes when I'm opening a data set, I maybe don't really know how to do it in Python. I am struggling a little bit, but I find like a good R tutorial for it. This way kind of helps me so that I can use my Python knowledge, but still kind of take advantage of some of those R tools that maybe I couldn't find in Python.
Okay. Okay. Awesome. Well, this is great. This was very cool.
Thank you. Yeah, I was excited about this. I thought that this was a really neat
Yeah.
neat thing. I wish there was one the other way around so that I could use R within a Python script, but I haven't found anything that is really the equivalent but opposite, unfortunately.
I think those were the questions. Thank you, Sarah. The presentation was awesome. Thank you everyone for joining in.